mo ni siya. Buha ka 1 meter ani niya. Okay? 1 meter agad imong gamiton. Okay? So para unsay ang imong kuha nga moment ani og shear 1 meter man niya. Muna mo gamiton nga mga force para pag-design. So whatever design or enforcement you will get is you are going to repeat that to the next 1 meter sa iyang sides. So, okay.
Excuse me, sir.
Yes.
Murag wala ka share screen, sir.
Okay, okay. Thank you for reminding. Okay. So, share. Yeah. Okay, so sa plan na to, mo na itong pan-design no? Ang iyang live load is 1.9 kilopascal. Remember, kilopascal so area dapat ani. Ang dead load niya is, ang weight sa floor ni siya, i-assume na ni siya nga 5 inches niya. Doon na siya mga tiles nga nipis pa. So, abot siya og ngani. So, it is 3.6 kilopascal. Now, sa analysis, base ka sa plano. You are not going to use the 6 meter width, no? Because imong design nun ani is along the 3 meters man. Mo man siyang giingon sa primero nga kung giingon ako dinhi nga the one-way slab is designed with respect to short span and the reinforcing steel is aligned along the short span. So this is the reinforcing steel. Now ang katong bars along the long span is ma-reduce na to siya o ngalan nga temperature bars. Okay. So this is now the picture of the short span, and then this is the corresponding shear and moment diagram with respect to the load. So sa atong example, this example, you are going to design a one-way slab for the following structural plan. So this is the structural plan. 6 meter ang long span, 3 meters ang short span. So you are going to design this one. So kining nakahas nga region is mo ni siya ang 1 meter strip nga width nga imong i-consider. So, ang imong design nun ani is good for 1 meter sa. Pero because of the repetition of the loading, so pwede nimo ma-adapt ang unsay design nimo ani sa abay. So, mo gyapon nga detalye imong gamiton sa abay. But you don't have the design anymore, okay? Imo naman ang design. So, what you will do is to repeat the detail of this 1 meter strip to the immediate sides, no? Yeah. So that's the strategy we are going to do. So because you add up 1 meter, we can compute now for the WU. So our dead load can be converted into, let's say, converting kilopascal, kilopascal into kilonewton per meter. So we will have dead load equals to 3.6 kilopascal times 1 meter. This is equals to 3.6 kilonewton per meter. Then live load will be equal to 1.9. This 1.9 appears in the National Structural Code of the Philippines for residential area times 1 meter. The 1 meter strip that I told you should become 1.9 kilonewton per meter. So that's how you convert kilopascal into kilonewton meter. So this is now what we call line load already. So in fact, this is a line. We consider the beam as a line. Now this is now 3 meter, no? The one that we are going to consider. Instead of using 6 meter, we use the shorter span. So in other words, your WU here, your because we in our the philosophy of design that we use is the ultimate. The WU is equal to 1.2 times 3.6 plus 1.6 times 1.9. Now, the resulting is how much? 1.2 times 3.6 plus 1.4, 1.6 1.6, 1.6 times 1.9. You have 7.36 kilonewton meter. Okay? So, this one really is that. That's for the previous design. This one also is aries. Is aries. Okay. So, uh, more niya siya. We will put that in the figure. It's the figure. Okay. Okay. Ano siya? So, we have W, so I can copy this one now. The shear diagram as the moment. In this, I can put. Okay. So, the shear is equal to is equal to 7.36 times 1.5, 7.36 times 1.5, we have 11.04 kilonewton. Okay. As for the moment, and near the support, we use the simplistic approach, no? So formula, I will put here formula for bending moment. So ako na siya i-save. So for the formula for the bending moment, sim- simplified. Simplified. Okay, simplified. I will use mu1 here as 1 divided by 12 WU L squared. No? This is for uh, at support. Okay? And mu2 is equal to 1 over 24 WU L squared at midspan. Okay? So, try to research lang sa inyong inyong theory of structures, no? Na kung ang okay. So, ang iyang load diagram ani niya is wala tayo load diagram ano tayo. Load diagram kompleto. Piling kopya ako. So, okay, so you have WU here. WU equal to 7.36 kilonewton meter. Okay. So since this is factored, so all your succeeding calculation like the VU and the NU are what we call uh, simplified also. So this one, as for this one, we have 7.36 times L squared, which is 9, divided by 12. So we have 5.52 kilonewton meter or near the support. How about at the midspan? So at the midspan, it's always like this. So divided by 2 again, divided by 2 again, divided by 2. 2.76 kilonewton meter. Okay? So these are the...
Sir, yun saan ang 11.04, sir?
Okay. So how do you calculate the shear if the if the load is 7.36 and this is 3.0? I will ask you. This is a theory of structures. How do you calculate the shear?
UDL times length sa sir, kanang UDL.
Okay, then divided by...
Divide by 2.
Okay, so 7.36, 7.36 divided by 1.5. Oh yeah, this is 4.9. Yeah, wait. No, sakto ba? 7.36 times 3 divided by 2, you said? So sakto
Ay,
ba?
di ba
Ibig sabihin,
moment arm na, sir, with ang 1.5?
what? Which one is moment arm here?
Ay, ang 1.5, sir ba? Kana, asa na? Yun sana, sir.
There's no 1.5 here. Where's 1.5? Do you mean? Kaya 1.5 nakita. Ang formula sa B actually is like this. U is equals to WUL divided by 2. You still remember this? For the for this particular figure, huh? For that particular figure. Anybody agree with me or agree with your class? What is the? You still remember the formula for the shear? How to determine the shear for this one? Because we are still in analysis, no? This is not design pa. So, kung sa to imong gisulti,
Ay, mura ka dumdum na watang kwan, sir, katong video ay magsirat.
kini siya, muna kato. So, muna ni siya. So, I just use 7.36 times 3 divided by 2. So, that's why you have shear here of 11.04. Then, it will go down din. So, 11, negative to 11.04. As for the moment, is equal to one half of the area of this. This is the area of this, 11.04 times 1.5 divided by 2. You start with negative because you have a negative curve like this. So you have two moments to consider, the 5.52 and 2.76. Then as if I'm going to choose, I'm always going to choose the maximum. And you have to be careful where to place reinforcement for this one. And you, of course, you reinforce the tension side. And the tension side is at the top. Okay. So we are now going to design. So our designing forces is I will make two. Uh, I will insert a table here. Okay. We have for for moment for moment we have 2, but I will use the 5.52, 5.52 kilonewton meter. This is what we call the INU. Okay, INU. That's it. Now for the shear, shear force is 11.04 kilonewton. Yep. So that's the name. So you start the design. So uh, this is number one, design forces. That's what you're going to determine. Number two is you're going to design the thickness of slab. So before you go on, you design the thickness of the slab. Now, from the book of Wang and Salmon, it's in chapter 8. There is a formula there that determines the thickness of the slab, no? So actually, the thickness of the slab, doon ay formula ni Ana, no? Ay formula na niya din and then the formula that is what suggested here, thickness of the slab is you have L over 20, L over 24, L over 28, L over 10. It depends, no? So I will just use L over 24. So this is ECI table Table 9.5A. So we have thickness, ano siya, ang gikanan sa formula. So thickness of slab, thickness is equals to L over 24. Okay, so for L nga equals to 3 meters or 3,000 mm, your thickness is 3,000 divided by 24, and that is equal to 155 mm thick. So that's the thickness of the slab. So your slab now is, you are going to consider the section of the slab as equal to this. First, you have the 1 meter, no, where's it? Shape, yeah, section of the slab. You have a shape, you have a 1 meter, yeah, this is 1 meter. Remember that we consider 1 meter, so this is 1 meter or 1,000 mm. Okay, that's the 1 meter nga atong consider sa atong analysis, no? Dinhi. So 1 meter ginagawa. Then ang thickness niya is this one. The thickness is 125. Then there's a concrete cover, so I'll put a concrete cover or steel cover. O yan na sila. I will say 25 mm. So na ako'y 1 inch, no? Pero according sa kuan sa ECI, ECI 7.7, ECI ECI 8.12. I'll just use 15 mm, no? 8.12. 25 mm is too much, no? But it still can be used. According to 8.812, you can use up to 1/2 inches. No? So, muna siya. So, ECI 0.812. There is a allowable of 1. So, I'll just use 25 mm. No? 25 mm as the concrete cover. But you can go as to 1/2 12 mm. Okay. So that means that my total thickness here is total thickness of 150. This is 150. 150. But your D is only one. D that's 150 for the whole, no? Whole. So I will clarify this. I will put dimension that this is the thickness. Okay. And then I am going to put again this one. I'm going to put this one. Okay, so thickness of uh, okay, so this is a total of 150 mm. That's the total. Okay, so that is the design section of your slab, no? 150. So you are going to adapt 1,000 by mm by 150. Now, as for the reinforcement, uh, that will be as follows. No, will follow na. Okay, you have already a design force. So, uh, Ang kuan man lang ko the thickness is dunay formula no na unlike beam no pwede ka mo assume diretso. So this one this is similar to a beam but remember class the kuan no the configuration ba is more of uh, wide ang iyang width and then narrow ang iyang depth no. Sa beam baliktad ang width niya usually narrower than the depth. So, muna siya ang characteristic sa slab ug sa beam. Ang characteristic sa slab is yung ani, no? Yung ani, sa beam, yung ani ang beam. Paana ang beam. Pa-depth ang beam, nana. So, ang slab, paani ang slab. Ana ang slab. Okay? So, muna siya ang kabaliktaran sa ila. So, anyway, ang design procedure is still the same. Okay? So, we have already done the analysis, so we will erase this part. And rather, we will continue to the moment, no? The moment. So, nanataan eh. Isa actually reason. Ah, so, okay. So, let us go to design, no? So, structural design. Now, our objective is here we have that one. No? Our objective is to make that one. So, we have already the design forces. This is this one. I will copy that here. So, we have already earned the structural design stage. No? So, muna na siya. Our objective is to make this one. So, step one is we have already the section. So, uh, I will just redo this. Step 1. So, ang BD dapat known na. So, I will adjust this. No? I will adjust this to fit our one. So, it could be like this. Then, I will erase this one. Save sa. Kuning erase Pagawas na ako. Ako ano siyang erase sa equal next. So, erase sa equal para sunod. Okay. Ini siya. Wala akong sinako siya. At ini wala akong sinako siya. Yung dark na line, ako siya. Ay, nag-group mo din siya. Ungroup. Okay, ungroup na. So, ako ni siya himuon una. Ito siya, ako ni siya extend. This is supposedly 1 meter. So, ako na siya establish nga 1 meter. So, 1,000 mm. Okay? Then, sa slab, usually wala na kay stirrups, no? Muna ni siya. No, we will answer that why. Why nga nung di na siya kinalag-share reinforcement. Okay. So, ato na daan gitanaw nga mas kuan siya mas adako kayo iyang share capacity. So this one is 150. So here is 150. This is 150 mm. 150 mm. Okay, 150 mm. Yung slot. 150 mm sa diha. Ano siya yung thickness. Okay? Then we put some reinforcement here. Reinforcement. Now, I am designing the near the support, so the reinforcing bars are at the top bars. Okay, and say that I have these numbers of bars. Okay. One, two, three, four. Kulang pa na siya. Dapat. So, muna na siya mga enforcement, no? Sa top bars. So, dili na nag-ingon nga, dili na po ka mubutang o butong bars. Butangan gyapon ni mo butong bars. Butangan gyapon ni mo butong bars. Okay? Butangan gyapon ni mo na butong bars. So, ang butong bars karon, ato lang nga naon, no? Home, copy, paste. So, lain na lang itong color. Ato lang, butang ang color niya. Asa ba itong format niya? Ini na lang. Okay. So, muna yung butong bars. So, gamay yung butong bars kay kan man na, di naman yung mga kan, dapat mas gamay ang butong bars. So, kan natin muna yung butong bars. So, natulog ka buo. So, basically, dapat nakakadani as known. Bawa na ni mo, no? Ang B is 1,000. Ang D is B is 1,000 mm. Ang D ni mo, D is equals to 125 mm. Kaya i-include naman ni mong concrete cover diha, no? That's the D. This is the D. The D. Yeah, ang ES ni mo, ES, there are 1, 2, 3, 1, 2, 3, 4, 5. So, tag 200 mo siya. So, you use 10M, Canadian Japon, 10M, kuha siya. Ang 10M is, may naana ko ang 10M din eh. Naman kay bars. 10M. 10M Canada, 10M is 11.3 diameter, no? 11.3 mm dia. So, 10 mm at how many? 1, 2, 3, 4, 5 at 200 mm. At 200 mm on centers. Pamot pasabot niya na ang imong ES is equal to 4 gina siya kabuk, no? No. Way labot ang isa ni. Kay ka at 200 man niya. 1,000 divided by 200 is 5 lang. So, that's equal to 5. 5. Wag 6 ang i-appear diha, no? Galing kay kini siya, gitunga mo gud ang tunga ani dito sa gawas, ang tunga sa ni sa gawas. So, 1/2 pagit ang count ani niya. Then this is full, 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 plus 1/2. So, you will have 5. So, this is 5 times uh, 11.3 mm squared times pi divided by 4, that is equal to, this is squared. Okay, this 11.3 squared times pi divided by 4 is the area of 1 bar. 5 is there are 5 pieces, no? Well, 6 ang i-appear pero kini siyang nasa side 1/2 lang count niya na. So that is 11.3 squared, 11.3 squared is times is pi divided by 4 is 100.28 times 5. That is only 501. It's only 501. Mm squared na siya. Mm squared. Okay. Mm squared. Now, as for the ES prime, ES prime, ES prime. So, instead na 3 may butang din eh, 1/2 bang credit ani nago sa kilid, ang 1 kini nasa middle, then 1/2, so this is 2. So, this will be times 2 divided by 5. So, 200, 200, 200 mm squared is prime ES. So, this one is still the same, I think. FC prime from my FC prime 24 and 250 for FY. 250 for FY. So this will become the same. Then there is no stirrup, so I will not consider that. Okay. Determine is corresponding to yield strain, so ma-compute man mo ni uh, kuha na lang ni siya, design extension na lang siguro ni siya, no? Design extension. We will not consider the the kuan because this is too thin, no? Too thin. So I will rather design this extension. So I will use the template on the previous example to ginato. No? Previous example. So I'll open it. Previous example, maybe nato sa start na siya sa mga June 9 siguro mga lecture na to. June 9. Pwede mo. Akong cloud. Open. June 9 na to lecture. Okay, so June 9 na to lecture. Doon na tayo. Example na to. Nga ako, example 1, no? Example 1. Deliver. So sa step 2 karon mo ni siya itong i-consider. Calculate Rn using equation 7. Dili ni mo. Okay. Tailored mo ni siya. Tailored. Natay example 2 nga trial section ang ihatag. Okay? So, sa trial section, we are going to determine the minimum row. Okay, the minimum row. Siya tako din. So, akong gikat itong nasa example number 2, ako siya i-paste din. So, dinhin na siguro niya siya na i-paste. Yeah, kasi na i-paste. Okay. So, we are going to determine the minimum row. So, we can determine the E is mean, no? So, since if Y is given, okay, since if Y is given as 250, so 1.3889, basically that's 1.4 divided by Y, divided by 250, you have a minimum row of 0.005, no? And then we go directly to A is mean. What is the minimum reinforcement required? So you multiply that by BD, which is 1,000 times 1,000 times 125 for the D. And that is equal to 694. Okay, that is the result. Okay, so we can have here E is mean equals to 694. That's the minimum. 1245 mm squared. Muna siya ang minimum reinforcement dapat nimo. But what happened here? Our E is 501. So meaning mas gamay pa ang atong E is kaysa E is mean. So this design is not okay. It's not okay. So we'd rather use maybe 8 kabuok. Kung 8 kabuok, itong gamiton 8 kabuok. So kulang ni siya, no? Kulang ni siya. 8 kabuok itong gamiton. Dapat 9 ang mabot mo, mulabas din nino, pila pa may ubok. 1, 2, 3, 4, 5, 6, 6 kulang pa nagtulo. So, copy ko. Paste ko patulo. Okay. So, anong siyam mo gina siya? Siya nga, walo mong kayo mag-iingon. Ang akong bot, ipasabot, ang count aning nasa mga daplin, 1/2 na siya. 1/2 na siya. Kaya 1/2 tungaon na siya din o dito. So 1/2 plus 1 plus 1. So 1, 2, 3, 4, 5, 6, 7. So 7 plus 1/2 equals 7 and 1/2. Plus 1/2 on the other side, that will become 8. So that means kaya doon na kay Uh, mhm. 11.3 x squared times is pi divided by 4, 100 times 8. So, dapat 802 ni siya. 802. 802. So, you see here that our E is, kunya, sa atong first nga example, tensyon naman itong gidesign na ni, wala ni ES prime, pero i-provide lang yapon ni mo na siya. No, dili gini mo nabiyaan niya. Why reinforcement kay ini ano reinforced part is prone to cracking. Okay? So, bisag wala siya gi-design, imo lang yapon i-provide. Na kay butang kag reinforcement, no. Butang tatulo imo butang, i-3 na to. No? So, doon na pa natin isa. So, nga na, ang dili na gano'n mo calculator, mo provide lang ka. Ang mo compute ito ang reinforcement sa top. So, your ES here, your ES mean, according to your FY, is 694.45. Kaya na naman kay 6 yun. So, nakita ni mo nga, mas gamay ay mong ES mean kaysa ES nga mong provide, which is okay. Okay. So, i-compute mo ang ES max karon. So, na-compute na ni mo ning imong Ruby, ini siya, ma-compute man nimo ni siya kay ngano naman tay kuan, naman tay si tawag ana value ana niya. So, panahon na ko 0.85 times 24 times 0.85 begin ng beta 1. So, you have 17.34 times 600 ayon. Divided by dayon o FY. Divided by FY. Divided by 250. Divided by pagkidayon of 600 plus FY. So, that will become divided by 850. So, ang ES max mo is point 0.85 times 24 times 0.85 times 600 divided by 250 divided by 850 is 0.04896 mo na siya ang imong max. Then times 0.75 times 0.75 na kay 0.036 times BD din mo na 1,000 times 125 you will have what's is max. So na kay is max na. Kapit na kay is max mo ha. Is max. So, compute nimo ang 25 times 24 times 25 times 600. Saglit lang. Okay, 55 times 24 times 25 times 600 divided by 250 divided by 850. 0.04 times 0.75 0.03672 times 1,000 times 125 45. So doon na siya ay 4590 m squared na E is max, no? E is max niya na. Okay. But what we provided is only 8 catin mm, 8 catin m, so which only amounts to 802. So we are still here, no? This one is satisfied. This one is satisfied. So, so mo ni siya ang hitabo, no? So if E is no no. So mo na siya. So wala tay gikuan diha, no? Okay. Okay na siya. So okay. So we satisfied that our ES is between here. So that means that our structure, our stale yield, no? This is the case. This is the case. So kini nga case ang bilinginan. Okay? Ano siya nitabo. Now we will compute for this one. So we will go to step 2, no? We will go to step 2. So step 2. Ito na yung reason. Okay. Ito na yung reason. Okay. Okay. Based on the lecture on June 9, step 2 is calculate the design nominal moment. So din na din tayo dito. Ano siya copy. Ito dito sa 14. So kini siya ato ni siyang pulihan o step 3. So ano siya taman. Okay, tama niya. Paste. So, calculate og moment na dayon kay okay naman ta din eh. Okay naman ta na namay okay ako naman yung giutihan. Or gipulahan. Uh, okay na ta, wala ta. Ang is nato na sa is max. Is max na po kayo. Ang is min wala. Ang is min is 694. Nya ang is nato is this one. This is our is. Pupipiyahon. Is. ES. ES. So, ES is equal to 1. Okay? So, wala ko gi-violate ani nga statement. Okay? So, mao na siya nahitabo. Okay. So, going back. Okay, so calculate the PMN. So, na naman ko ang actual row nako, compute man ko sa actual row. So, row is equal to this one. Happy. Nga naman maka-compute na ko, kaya doon na naman ko i-ES. Ang i-ES na ko is 802 man. So, 802 divided by 1,000 divided by 125. So, ang i-ES na ko is 0.006,416. Mo na siyang actual i-ES na ko. That is based on the i-ES nga akong gi-provide nga walo ka buok ko, walo ka ka 10M kunya kuan. So, pag-hope lang ta nga makuha na to ang kuan sakto nga answer, no? Nga kuan nga moment. So, A is equal to A is equal to, so with that na nako yung row, so multiply din ako og Fy na may formula, 250 times 125. Okay, 0.006,416 0.006,416 okay, times 250 times 125 divided by 0.55 divided by 24. So na ako is na 9.828 mm. Now, this is my A. No? I can compute my C. Compute na ako ang C. Kaya ang C, mo yung formula, oh. C, so, pagto ko sa C, but actually, that's just C na siya. No? Kuha na siya, standard na formula, CC na siya. Pero, ay lang, kalibog kung C lang na siya diyan. CC is equals to 0.55 F prime of C times AB. Okay? O na siya ang pan. So, kini siya, subscript ni siya. So, makompute na din nato ni siya. Kaya nga naman, naman ta ng FC prime of EB. Naman ta na. So, 0.85 times 24 times A nga equal sa equal to that equal to 9.828, okay, times B din yung 1,000 times 1,000 na kay CC na 200,000 for 91 Newton. Okay, Newton na siya. That is 0.25 times 24 times times 9.828 times 1,000 na yun na B. That's 200.291 kilometers per tayo. But A is very small number, so you can calculate in N. All of the variable here, natay A is, natay point, natay B. So, compute like in N. This is equal to, I think, 802 ni siya. Okay, 802 ba yun? Oh yes, 802. That's 802. 802 mm squared times 250. Then ang solve sa parenthesis is this one is 9.828. 125 then 125 minus 9.828. So ang unit niyan is Newton mm. Okay? So we have in here at the below. Okay? So nauna to nasa parenthesis 125 minus 9.828 divided by 2. So that's 120 mm times 802 times 25. Oh no, 250 day. Is equals to 24, 24, 077, 243 Newton mm. So, i-convert niyo muna sa kuan. Ngayon mo na siya 24.077 kilonewton meter. Now, with F equals to 0.9, 0.9, di ba na siya F, kundi P, we can have a PMN, if PMN, minimum, PMN equal to, multiply na po siya, 21.667 PNN. So, there. Sumpay na siya dito. So, okay, so, naana ni siya dito, no? So, nakuha na ni mo ang T, actually. Pagkuha mo sa MN, lagay mo na siyang CC times D minus C over 2. Pag kini siya, muna ni siya dapat na nasa step 1. No? Step 1. So, wala na tayo step 1. So, mauna siyang labas at naning reason. Okay. So, is PMN greater than MU? What is MU? MU, if we go back to our analysis, mauna siyang demand. MU is 5.52 only. So, therefore, the assumed section is yes. Is yes. So, you're going to check for PBN. So although our BU is only very small from our calculation, that's only 11.04, but we can calculate the PBC. So we can calculate this one so that I can explain to you why we did not care anymore. No? So this is 11.04. This is 11.04. Kunya, pag solve legal na to sa PBC, no? P equals to 25, wala labot na ning PBS, kini lang PBC, kini wala na ni siya labot. Lahi wala na to ni siya. Ito na, ito na siya ibutang din. Ito na to diya. No? So sa DC palang daan, no? Ito ni siyang ilisan BD mo ni siya, mo ito ni siya 1,000. 1,000 times 125. Yan, BD na mag-init yun sa 125. Okay? Take 24. 24 square root is 1 divided by 6 times 1,000 times 125. Kini pa lang daan gani is 102 na. 102 na siya. 102.062 Newton. Or this is equivalent to 102. 102.062 kilo Newton. So, kini pa lang daang BC, kini pa lang daan BC, naku na kayo, no? So, BC pa lang daan, BC pa lang daan is 102 na. So, bisan pag dili nimo ilabot ang BS, doon na kay kuan, kini dili nimo i-count, imo lang na siya imong zero. So, dili na siya zero ha. So, not include. Not include. So, we just count 102 PN. 102.062. So, mo na yung value sa BN mo. 102.62. 102.62 kilonewton. Now, imo na siya multiply by 0.75. This will become 0.75 times 102.62. Dako kayo. No? Ang PBN ano niya, if BN is equal to 79, 79.65 PN. So, that's it. So, here, we can see that PBN is greater than BU. So, uh, the section does not need the section. The section does not need shear reinforcement for the reason that the shear resistance of the concrete is very big compared to the actual shear. Okay, so this formula is not needed. Okay. So in our detailed drawing, the the section per meter will look like this in our detailed section. So section at support, this will be the one cut. So the section at midspan will be for the next. So the detailed drawing is like this. No? I will just copy this. Ay, hindi na. So I will just copy that. And then drag this to next. Go to the next. ate yes. Huwag yapon yung i-adapt din sa section below the midspan, other midspan. The only thing that is difference is that the sectional support, the main reinforcement is at the top. So that's the one. And then there are plenty of that. There are two, three, four, five, six, seven, eight. So muna siya iyan mga kauban ng reinforcement. Okay. Muna siya iyan main reinforcement. Patuloy gina siya. Mga reinforcement sa slab. Okay. So, muna yung mga reinforcement. So, ako dibutangan niya. 1 meter ni siya. 1 meter. 1 meter niya. Ubos. Ay, ako lang ni siya ikuan. Ilusa siguro. 4, 5, 6, 7, 8, 9, 12 siya. Okay. So, i-drag ko na sa ubos. I-drag ko na lang siya. Okay. And then, butangan ako na siya o 8, 8, 10, and steel bars. Steel bars. Up bar. Okay. And then, I just use another insert here. Even though I have not made computation, but di na ko limtan. Tangan ko na siya og itawag nga compressive reinforcement. Okay. Compressive reinforcement. So ako lagyan po ni siya yung group. Dahil na po kopya. Okay. So, ini siya din ako limtan to butang. 150 na siya kay giakit na lugar ang concrete cover. Pero kung ako ni siyang i-move mo dito, 125 o gina siya. Total depth na niya. So, butangan ako ni siya o 3 ka 10 mm, 10 mm, steel bars, bottom, no? Bottom. Okay. Mao na siya ang sa section at support, no? Section at support. Now for the section at midspan, it will look like this. So this is still 1000 mm, pero ang imong top bar mahimo na lang mahimo ni siya kada to 3 na lang ni siya 3 ni siya kay di man importante ang top bar sa midspan steel bar. So mali siya top. Yeah, this is yung sa ubos and then 125 din siya 150 dahil 150 niya kining siya kaya ko na siya yan na to siya ibutang sa taas niya dinitay ko kaya ko na siya. So, muna siya itawag na 8 ka 10 steel bars button. Okay, so I will save this. This is the typical section, no? So, kada 1 meter lang ni siya. Sa ito pang next 1 meter, imo lang ni siyang i-duplicate unsay design na niya diha. Mo gyud na siya diha. So, Now, I am going to ask you, no? Nganong nibalin man ang bottom bars sa midspan? Nganong daghan man ang bottom bars sa midspan? Sa may buot pasabot ana niya. Anybody can answer?
Nalasubos ang tension, sir.
That's correct, no? You reinforce where tension is. Nya ang sa top ba, ang sa top portion sa midspan kay compression man siya, nya atong design kay tension reinforcement only man. So di na nato design nun ang number of bars sa top bar pero will provide few. We call that compression reinforcement. Napay kulang ani niya. Unsay kulang nato? Pali-pali. Anybody? Makaingon? Doon ako isa ka reinforcement kaniya nga lahig ngalan. Ano sa man ito yung ngalan nato niya?
Shear reinforcement, sir?
Ato naman giingon dinhi nga does not need shear reinforcement. No tayo reinforcement kaniya nga akong ipakita sa diagram nga wala pa nato na kuha. Aha, may ato isa. Kung sa pailain mo sulti, dapat tayo reinforcement ka kulang. Nga dapat imo ginang ibutang bisan nung wala ka nag-compute. Anybody? Kining along the long direction ng bar. So, ato lang na siya ibutang na record niya. Ito yung format. Ito siya. Ito siya. Okay. Yan, ito siya. Doon na siya. Ito yun. Hindi siya ibutang. Mapilagyan po niya siya din. Oops, sorry. These are what they call temperature bars. So, butang na lang ni muna siya legend. Legend. Tip bars. Okay, that's it. Tip bars. So, sunod pa, butang niya pa rin mo para complete yung detalye. Okay. So, okay. So, I will save. So, as a recap, no? Recap ta. Recap ta. Okay. So, sa atong pag-design karon, mauni ang area sa kuan, ah area sa imong slab, no? Ano, oil sa nimo ni siya mga beams kay gapalibot sa iya, no? Now, this is 6 meters by 3 meters. Kung design lang ka along the 3 meters, no? So, mo consider ka og 1 meter. So, kung mukat ka og section, this will be the the figure, no? The elevation. So, yun, ang beam nimo as line. So, kung line siya, dapat line load siya, kilonewton per meter. Yan. Yeah, ang load nato nga given is in kilopascal. So that means you are going to convert that to kilonewton meter. The only way is to consider a 1 meter strip. Now, kini 1 meter strip mo sa mo ni siyang technique nga gamit kung pareha-pareha la ang iyang design. So isa lang imong design nun, and then whatever imong mga design nga nakuha ani will be duplicated to the other. So Whatever we get here will be the same reinforcement on the succeeding sides per 1 meter. Okay. The purpose is to have the initial calculation of the weight of the dead load and also to determine the live load at that particular strip. So you can calculate the load for that particular strip. Now for 1 meter strip, niabot nga 3.6 kilonewton meter and dead load nga 1.9 ang live load. In other words, if you are going to compute for the ultimate load, you will have a 7.36. Now for the span of 3. Now because this is a beam, ang consider niya, one is siya kanang gitawag nato og fix, no? Fix ni siya sa theory of structure ni siya, fix ang iyang symbol ani niya, no? Naka-hats ni siya dinhi. So that means nga this is the depicted shape. So as for the shear and moment, this is the shear and the moment with respect to that load. So this will be the demand or the design forces that you have, no, or the required forces. So in lieu of software, I use formula in the book for that particular figure. This is just simplified. So I got a moment of 5.52, 11.04. By the way, the 5.52 is the maximum for the two. No, I use only one and I adapt the same section, but I only reverse the location. Like for example, for the mid span, I put it, I put the main reinforcement at the top, and then I ask you why I transfer the location of the main reinforcement at the bottom, and you answer it correctly because the tension at the mid span is at the bottom. Okay, so these are what we call uh, shear force. Okay, so another important for the slab is you design the thickness. Now, this is just one of the formula. No? This one is already okay. So L over 24. Whatever L here will be divided by 24. That will be the thickness. Okay, and then you add a little, no? Complete cover according to ECI 0.812. So kung slab gani, gamay lang siya, dili siya maabot og katong 40 mm or 1.5. So that's why with the thickness of 125 plus 25 mm, so I use 150, no? 150. And then I have already trial section, so I have to put my reinforcement, no? I have to, this is the type of design nga i-assume pa nimo ang tanan, no? Ma-assume ka og section. Now ang width ug ang thickness niya is determined in the previous calculation. Ang imo na lang i-assume dinhi is the E is prime. Tungod kay mao kuno ni ang known B, D, E is prime. Pero dinhi pwede na walaon natong E is prime, no? Atong walaon. So sa atong calculation ato may consider, no? Kana lang, no? Kay kuan naman ni siya tension reinforcement na atong gi-compute. Okay, so I have 1,000 D and E is I consider at 125 mm on center, 125 so tag 5 inches on center, and so I unuse it. So of it I can have it also. Now nagduda ko nga basin og gamay ra kayo ang 802. So I computed the minimum reinforcement, and it turned out that the minimum reinforcement required is 694, which is lesser than what I plan to use 802. So I also calculated the maximum, and the maximum is very high, no? Just because of the size of the slab, which is 1,000 by 150. Okay, so you can increase the reinforcement, but as we have found here that even though 8 ra ka 10 mm, ipasar na siya, dako na kayo ang clearance niya. With 8 ka buok 10 m nga diameter, nakakuha ako og design capacity nga 21.667. Unya ang inyo 5.52 ba ya? So dako na kayo. Now, og imo sang ubsan, like for example, ligamit ko ganiha og 5 lang ka buok, nahitabo adto mas digamay siya sa iismin. Dili gini mo ni siya ubsan, no? So I maintain using 8 m, so I have it auto. So I'm computing the AS max for 590. So I still in between AS min and AS max, which is okay because this is what the code you to follow, that your reinforcing bar will not be lesser than the minimum required and not also greater than the maximum. So it happened that ito to is in between 694 and 4590. So okay, that's okay. So now I calculate the PMN because I have already the AS and BD, so I can calculate my actual reinforcement ratio. And then I can also compute the A. It just happened to be this formula, so A is only very 18, no? 9.828. No? So this is the figure, that is where your CC will act. A is very thin, and then you have the T, which is the AS times Fy. So basically, I can calculate AS Fy and I calculate CC because I can sum up forces horizontal here. C is equals to T. So I can calculate CC in this formula. So CC is 200.491. This is also equivalent to AS Fy. Okay. Now, to calculate the moment, because these two are equal forces but not collinear with each other, so meaning there is a couple formed here, and that couple is the moment or the capacity of the section. We call that Mn. So that is basically A is Fy times the lever arm B minus E over 2. And it turned out to be 24.077 kilonewton meter. And multiply that by zero point 0.9, so I have a PMN equivalent to 21.667, which is very, very high compared to the actual factor load na 5.57. So, is this safe? And then the answer is yes, because PMN is greater or equal to NU. Okay, yes. Now, the reason why slab have no shear reinforcement is because the capacity of the section is composed of the capacity of the steel bars and the concrete. Now, concrete pa lang daan, niabot na siya og 102.62. Niya, ang atong BU is only 11.04. So, dili na ko maglangan-langan pag-solve to DS. Kay sa concrete pa lang daan, dako na kayo og capacity niya. Kaya siya mabuak. No? So, ang BU na 11.6, 11.04, dili makabuak sa simento kaya ang force nga ginalan mabuak ang simento is 76.96. So, 11.04 lang. So, di kita maabot. Now, bisan pag mabuak siya, kaya in actual, we have reinforcement man, so, dili gyapon. So, this section does not need shear reinforcement. Now, because I have already determined my section to be safe in flexure and shear. I also designed the thickness according to the criteria in the formula. So I can now do my section. So there are two sections that you are going to do because you cannot maintain this section throughout because here in the depicted structure, your tension transfer from top to bottom. So your reinforcement also will follow. Aha ang tension. So that's why in your detailed drawing, ibalhin ang top reinforcement sa bottom. Switch sila. Okay? Simply because there is a shifting of the location of the tension from top to bottom. So, whatever section imong nakuha dani is kopyahon lang nimo na siya sa tapad-tapad. Masabtan na sila sa actual kay kada meter mo na ilang reinforcement. So the next 1 meter mo lagi hapon until mo balhin sila sa lain na pud nga slab. Okay? So the topic that we have this morning is a different topic, designing of slab. So one-way slab. And even though dunay two-way slab, designing one-way slab lang is enough na nga maka-design na ka og slab. Kay kung kuhaon nimo ang moment sa other direction, so instead nga mo gamit ka og gitawag na temperature bars, min bar na pud mo gamiton dito. So lahi lang ang shear og moment na pud nimo. Analyze na sa nimo ang moment sa other direction. So kaduha ka mo analyze, no? Kaduha ka mo analyze. So kini siya kaisa. Okay? So do you have any question?
Sir, may question, sir.
Yes. Question. Okay.
Sir, asa ka mo kuha og strip, sir, sa short span or sa long span nga kuan?
Sa short span kay mo design mag-along sa long span. Along
So
sa
i-base nimo dito ang kuan, sir.
Oo, 1
Dito
meter.
yung 1
So,
meter.
ibayon nimo tong 6 meters ang kaunom. So, kaunom to siya. So, unsay imong gi-design sa first 1 meter, awaton na to nimo. Basta aya sa to nimo awaton kung nakita nimo nga safe siya sa moment sa shear. Dili ka mag-design og dinhi nga 1 meter ang akong thickness is 125, dito 150, dito 200. So mag hinagdan ang imong slab. So isa lagi kita sa thickness. So whatever thickness imong na-design sa isa ka seksyon, mo sa to imong waton. Unya para dili libog unsa tong reinforcement nga spacing sa imong o pila ka daghan nga top reinforcement ug bottom reinforcement adto nga 1 meter, mo sa to imong awaton sa pikas para isa ra instruction. Okay?
Yes, sige sir. Salamat sir.
Okay. So any question?
Sir,
Hello,
kanang
Yes, Baga.
Ay,
Si kinsa may una, si Baraga o si Darapa?
ay ikaw na lang una sis, go.
Okay, Princess. Miss Darapa. Miss Darapa. Hello. Aubrey, ikaw na lang, Aubrey.
Sir, kanang kato ka ganina sir ba kanang dili siya gasto ra kayo ang kuan sir if inadto marag dako ang ligas, di siya gasto like di ba gamay ra ang required tapos murag dako biya kay to ang ligas sa ano.
Yeah, you're correct, no?
Dili siya
Actually,
gasto kayo. Unsay possible na
dili to siya gasto.
i-alter to sir?
Dili to siya gasto kay ngano kung ubsan sa nimo ni violate naman sad ka sa iismin. Kay ang iismin og ang imo actual duol ba kayo. 800 to ang imong gi-provide. Unya ang minimum is 600. So kung imo tong kuhaan, pwede pa to kuhaan isa lang ka kabilya. Pero,
Okay.
bro, madugay naman gud ta, maabdan niya ta og alas 12 na po.
Sige, sige.
Ako na to give
Pero,
and take.
ang kabilya, ang i-alter to, sir.
Kuhaan. Kaya ang thickness adto dili naman to nimo makuhaan actually. Pwede to nimo makuhaan kay like for example, mogamit ka og 12 mm. So kamay ra kay makuha nimo adto. Kay doon naman yung formula sa ECI. Gawas kung mo violate ka sa formula sa ECI, okay na ni. Pero ang problema man gud og ma-violate ka kung doon ay mga kaso-kaso, katong yung libro ang basihan di aga kanisunod mo na nga ni bawog bagayo imong slab ni tawag na ni yut ni ana ni sag ba kay kung nipis mo kayo mo sag mo na siya so mo na ang control sa thickness so ang standard diha o ang kwan diha is you do not violate what is in the code so tama lagi ka sa pinakanipis diha mo gid mo Although dahil kayo nagamit ka og nipis nga slab because na dili naman lang good kuan nga atong kuan do na tay mga other formula ba coming from Europe, coming from Japan, coming from China nga ang ilang gigamit so ingon tang ay gwapo mo nila waton sana so which violate also already the code nga atong gigamit but it depends sa gyapon.
Sir, sa sibli dili ka mo adjust sa thickness pero pwede ka mo adjust sa kuan sa kabilya sa
Yeah, pwede mo adjust kabilya. You can limit up to the minimum. Instead na 800 mong gamiton, katong minimum mong gamiton.
Yes, sir. Thank you, sir. Thank you, sir.
Instead na 8 ka buo,
hello, sir.
8 or 6. Yes, Mr. Rapa.
Hello sir, pwede pa check ko nung email niyo po. Medyo important po siya and
Okay, I will check it, Mr. Rapa. So I am going to check it today. So any other concern?
Sir, katong quiz, sir. Magkatong extend sa quiz.
I will one. Pamasit mo maabot, no?
Yes,
So,
sir.
thanks for reminding. I will one.
Salamat
you, sir.
sir.
Okay, so you be sure to submit it today because that's a quiz, and then I am also going to give another design of a slab. Di Saturday na lang, no? Saturday na lang, no? Tagaanta mo og time nga mo padayon sa inyong kuan kay inyo nga kabulo pagabuhat ng inyo, no? So buhata to ninyo para makamaumo para kung kamo na niya mag-practice dili lang kay mo gamit mo software niya madawat mo sa resulta sa software mo kabalo para gyud sa testing din mo design, no? Such as the ining akong gibuhat nga quiz number ko sa inyo kuha din yun na so okay na kayo na siya, no? So I will stop lecturing now, so I will leave